Hi everyone, welcome to my first Zoom meeting. I'm going to be speaking to you today about the information we covered for our first assignment in Module 1. We began by covering different body movements and speeds measured at miles per hour. We discussed or learned about Earth's rotation, the orbit, how our movements are affected or affect not just what we do, but you have to take into consideration everything else that is in play, working in harmony at the same time. Again, speed of the solar system, the galaxy towards the Milky Way, the orbital speed of the Milky Way, the speed of the local group. All of these are measured here. You can see in miles per hour. Here's the accompanying pie chart that represents each of these in percentages. Earth's rotation, the orbit, and so on and so forth. And here's the graph that measures the body movement speeds that are discussed right here. Then we got to watch this really cool video or slide scale video of the different size and volume of pretty much anything you can imagine that exists. I deemed the coffee bean to be profound at that moment, not realizing it's actually a fruit. I found that to be incredible. Given that it was early in the morning when viewing the Zoom video, the coffee bean spoke to me, and I instantly felt energized. If I were standing on the equator, I would be moving at a speed relative to myself. The miles per hour at which I'm moving is relative to so many other elements, all working in harmony and in motion with each respective movement. In the moment of its existence, both large and small numbers are used in scientific notation depending on whether or not they represent a positive or negative value. EX and E negative are represented in the formulas used in Excel spreadsheet and on scientific calculators. However, they're not written that way, but instead represented in algebraic terms using powers of representation. Our next portion of our assignment, we covered unemployment rate or percentages for the presidents, specifically during the Clinton years and the Bush years. They're played out in percentages here and demonstrated on these graphs here and here. Then we looked at bowlers and their scores, and we got to work on how to best graph those. We see 3 players represented here, Diana, Hilda, and Emily, and here's our scores. And then they play out over here on the accompanying charts. Moving on down to the next section here is a look at arena funding by percentage. The contributors and represented in millions of dollars. Here's the city, 265, unknown, $10. And the Maloof funding was 85%. This was information gathered based on the chart in the slideshow. We were to determine which slides and charts and graphs could be construed as conspicuous or falsified information or misleading. So we tested them by making charts and graphs. Here's the Maloofs, 25 or 21%. 65% for the city. And then a company over here was broken up into percentages represented over here on this pie chart. And here we see the percentage of sales. Let's move over here and make sure I didn't miss a graph. Then there were surveys that were conducted, or discussed rather. A lot of those surveyors' research and data are useful tools. They demonstrate the proposal or the objective that is being discussed, and however, some might be tempted to falsify or inaccurately inflate information to slant the results in their favor or create bias to push their agenda. Graphs can mislead the viewer if the starting place data is skewed to manipulate the outcome. And so we had a chance to look at some of these to try and determine if they were accurate or skewed in some way. The Cortera graph was measured by using a replica of the shape and inputting a relative size in the shape's properties. Next, a formula was used to calculate the percentage using pi multiplied by half of the diameter to compute the radius in both of these. It was then divided by the same formula used to determine the size of the smaller shape right here to see its percentage. Other ways that data might be misleading include flawed questionnaires. For example, leading questions that could be biased or have response choices that aren't mutually exclusive in nature. Additionally, poorly executed interviews by the interviewer. Example would be not asking the question correctly or thoroughly enough, or asking the questions in a inconsistent, non-standardized, or non-neutral manner. In future, I'll strive to make sure data-driven decisions incorporate accurate, reliable data. They have consistent, standardized, neutral methods. And I'll also employ some of the techniques learned to investigate and verify the data given to test it and validate its accuracy. Here was a test over here. I worked out that formula to see if this information was accurate. The third portion of our assignment discussed the American population and those who deal with obesity, high blood pressure, and type 2 diabetes. We can see the breakdown of Americans in millions, 326.2 million represented. The percentages are broken down over to the side here. For instance, the type 2 diabetes percentage of Americans with type 2 are 34.3%. That's a 10.5% of the population. Then we use the Venn section to help calculate our results. And these are the results of the Venn calculations over here in this last column. The data represented is the American population. Again, it's broken down into those who are affected by health issues such as obesity, type 2 diabetes, and high blood pressure. It's sorted in the Venn diagram over here, ascending to the assigned to the ailment or combination of ailments, respectively. 10 million Americans, or 3.1% of the population, struggles with obesity alone. 9% of the population deals with both obesity and type 2 diabetes, and likewise 9% who struggle with obesity and high blood pressure. Still, 8.5%, or 27.7 million Americans, deal with a combination of all three. Arkansans rank 7th in the nation for obesity. This could likely be attributed to low income, poor diet, as well as several social factors. The statistics are the same in neighboring states, and the population tends to be less obese in the western states. This could be contributed to warmer climate, but perhaps linked to more government intervention and overall healthier lifestyle choices for the population ratio. It's also likely that the food culture plays a key role. For example, the eastern states tend to use less grease in their diets than many southern states. There's, of course, the link between stress, high blood pressure, and given statistically lower income rates and poverty levels of some of the lower performing states, one cannot deny this connection. And again, over here are the pie charts that represent the calculations. 10 million obese, 4 million with type 2 diabetes. High blood pressure is 23.4 million people. over here represented in percentage, 7.2, 0.1, and 3.1. And then these sections right here are those Americans who deal with a combination of 2 and or 3 of these ailments. Moving on to section 4 of our assignment, we looked at the height of Army recruits based in inches. There were 9 of them that were studied. Here are the inches over here and the recruits listed. There were 9 studied. We do notice that the median or average height of the Army recruit was 72. Not much fluctuation on the trend line. This is evidenced right here. The coefficient of variation is markedly subtle. There's only a 4-inch standard deviation. In contrast, there's a much greater fluctuation occurring in the heights of the random mall shoppers that were also, we also made a chart for to see what their average height was. So we have these to compare. Again, there was greater fluctuation observed on these charts. You can see the difference here. The standard deviation is much greater. So as you can see, it's the broader demographic collection was observed most likely. There's a 14-inch standard deviation and an increasing coefficient of variation over here in our little mall shoppers. We were tasked to note this in what is known as a whisker box. I would like to point out I do not have whisker box option in my Excel, and so I had to choose a chart that was similar looking. Hopefully I won't get counted off too much for that. Down here are what should be the whisker charts. I use the line graph here. You notice, again, not much fluctuation in the Army recruits, whereas over here in the mall shoppers, there's quite a bit of a difference. And then we've got our variations listed with our median, our means. That was the tallest, and there was the shortest. And then finally, the 5th portion of our exercise, which discussed the average amount of sleep obtained by a poll that studied 217 Duke University scholars. The arch represents the mean or average amount received is 6.7 hours. Here's our little arch. 6.7 hours of sleep at night. The standard deviation allows for a 2.3-hour fluctuation in that time. It's probable to fall, I do actually fall somewhere in between the standard deviation. It is probable on the sleep curve. Here's my line right here. My Z-score landed me between 4.4 and 6.7. My average 5.8 hours of sleep at night. The measure of distribution or median income we can see listed on this other graph that we viewed for America is $48,440 annually based on the data collected and provided. This chart is skewed, definitely, filled with inaccuracies. It's not normally distributed and cannot have a standard measure given the vast amount of categories there are to choose from. This chart's based on archaic factors and leaves out modern day norms, such as most homes are comprised of 2 wage earners. Also, not every option should be factored using the minimum wage. The facts are therefore distorted on this chart that we had to choose from. So that one is definitely needs to be reworked. And then here's some of our calculations over here. As you can see, the norm distribution as it correlates to the chart given. Overall, this assignment was very eye-opening, very informative. I learned very much, and I look forward to the next assignment. Thank you.